These are the 3 most missed. Actually, I think I chose 4 most missed on the quizzes from today. So regardless of whether the independent variable is called x or theta or beta or alpha, it doesn't really matter as long as the independent variable here is the same as that here. Otherwise, we move into a different integration technique. But this is exactly the same procedurally as doing this. The name of the variable doesn't affect the process. So when we do the derivative of a sum, you can do them differently. So you're actually taking, if you were to write it out the long way, the derivative with respect to theta of the square root of theta plus the derivative with respect to theta of 3 sine theta. Now, I don't require you to write that out. You can just know that you can break sums and differences apart. With products and quotients, though, remember, that's why we have a product and quotient rule. You can't just do them separately. So I like to bring constants out front. So I'm actually taking 2 times the derivative, and if you want to change it to x's to make it easier to work with, that's fine. This is just saying instead of x being what's changing, an angle is what's changing. Doesn't matter. Procedurally, we'll do it the same. All right? I still, too, like to bring constants out front. I'm showing it the long way just because when we're prepping for a test, I want to make sure that you understand why we're doing what we're doing. So again, constant, you could say, well, isn't this a product? It is, but if you did first d second plus second d first is 0. Same here, if you did first d second, you'd get what I wrote, plus second d first is 0. So the constant multiple rule says if one part of the product is a constant, you can just bring it out front. So I'm really taking the derivative of 2 times, we bring the power out front, we knock it down 1, plus 3 times the derivative of sine theta is cosine theta. That needs to get memorized. Remember, saint, cloud, negative cloud, and it ends the way it begins, and we do our derivatives on down. The derivative of sine is cosine. So then these cancel off. I end up with theta to the 1/2 plus 3 cosine theta, but you'll see that all of the possibilities here are written as a single fraction. So we get rid of negative exponents always. So that would be 1 over root theta plus 3 cosine theta. And then you can picture getting a common denominator. I like crisscross applesauce. I like 1 plus 3 cosine theta. Sorry, 1 plus 3, my screen moved. So I've got 1 plus 3 cosine theta root theta all over multiply across. And if this was a heart and I broke it apart, you'll notice I get 1 over root theta plus 3 cosine root theta over root theta. And it'd lead me right back to where I need to be. So that looks like it is option D for this one. 1 plus 3 cosine theta root theta over theta. All right, the next one. This is a parabola meeting up with a line at 2. To be differentiable, first of all, we have to make sure that the function's continuous. So I'm checking that there's no holes. There's not, because there's that less than or equal to, greater than or equal to. Then I plug the 2 in. I'm really seeing if the limit, now it's multiple choice, you don't have to write this, but if you have to justify it and say an FRQ, you'd say the limit as x approaches 2 from the left of f of x, I'm on the parabola. And I get 2 squared plus 1, which is 5. So that means I'm at 2, 5 on the parabola. The parabola opened up from 0, 1, so it's kind of looking like that if I were to sketch it. Then the line comes in, and I take the limit as x approaches 2 from the right of the function, which is the bottom part of the piecewise, and it's 4 times x minus 3, which is also 5. So what that's telling me is I can keep going. Had I gotten any other number, I'd have it wouldn't be differentiable because it's not continuous. So right now I know I've got continuity, okay? So it's not this one and it's not this one. That line is taking off directly from where the parabola left off, all right? And it's solid right there because the parabola closed it. So the next one is we have to make sure that the derivatives match. So this is forcing continuity, and then the homework I'd always branch off and do it separately. Now I have to make sure that the limit as x approaches 2 from the left of the derivative. I call this d left equals d right sometimes. Limit x approaches 2 from the right of the derivative matches up at 2. So I have to make sure that it's not only continuous, but that there's no sharp turns. All right, so I'll take the derivative from the left. The derivative of x squared plus 1 is twice x. I have to check and see if that equals the derivative of, as I come in from the right, the derivative of any line is just its slope, and I'm checking to verify that that happens at x equals 2. And 4 does equal 4. So this is both continuous and differentiable. Its graph, if I were to graph 4x minus 3, it'd be down here, and it would go up 4 over 1, up 4 over 1, and it would take off like that. So you wouldn't even see that as the parabola ended where the line began. We know it's at 2, but if you graphed it, like I think I showed one of these on Desmos last week, and it really just looked like one big parabola, when in fact I had entered a piecewise function, but I made sure that it was both continuous and differentiable when I entered it. The next one of the most missed was an equation of the tangent line to G. So we're going to be working with G. We'll not focus on the F column. All right. And so we need a point on G. That'd be 1 comma G of 1. Or equivalently 1 comma G of 1 is negative 1. And we need the slope there, also known as G prime of 1, or the derivative. G prime of 1 is 2. So then we say y minus the y we know is equal to the slope there times x minus the x we know. And we get y is equal to, and you can leave this if it's an FRQ, but this was multiple choice and it was solved for y. So y is equal to 2x minus 2 minus 1. And you were supposed to have entered 2x minus 3. So anytime you're asked for the equation of a tangent line, you need a point on the curve, so I know, well, where do you want me to get this equation? And then I need the slope. The slope is always the derivative. This one was tabular, so I found my slope off a table. Sometimes it'll say, you know, if f of x equals 4x squared minus 2x, find the equation of the tangent line when x is 0. Well, you put in a 0 and you get a 0 out. So my point on f is 0, 0. But my slope there is, this is a bad one, 8x, oh no it's not, 8x minus 2. And when I put a 0 in now for the x, I get 8 times 0 minus 2, or negative 2. So always point and a slope, okay? And the last one was this one. I didn't screenshot all the possible answers because they were super tiny. You wouldn't have been able to read them. But it asked for which shows the correct limit procedure, and it used delta x. So we need the limit as delta x approaches 0 of. And all of them had the limit on it, but sometimes I've seen these where the limit's left off, so you immediately know that's not one of them. And we do f of x plus h minus f of x over, oops, h is the new delta x, it's the same thing. All right, all over delta x. Okay, limit of x plus h minus f of x over h. Now remember, the first thing you need to do is get that x plus delta x down. So x plus delta x goes into the function. So it's going to be x plus delta x quantity squared minus 3 times x plus delta x. So you put that in first. When you FOIL, you'll get an x squared plus twice delta x plus delta x squared. That's the FOILing of this. Minus 3x when I distribute, minus 3 delta x. That's my f of x plus delta x. But I'm also supposed to subtract f of x. So I'm going to take the equals off so I don't get linkage. I'm supposed to subtract, oops, I meant to grab a highlighter, f of x. And f of x is all of this. So I'd go minus x squared minus 3x. It's all over delta x. It's all a limit as x approaches 0. Delta x approaches 0. So the correct answer that was listed was x squared plus 2 delta x plus delta x squared minus 3x minus 3 delta x, and then this was distributed in. And so it was minus x squared and then a plus 3x. Make sure you can recognize that formal definition of the derivative, both in that context and maybe if it was something like this. Limit delta x approaches 0 of 4 over 1 plus delta x minus, I'm trying to, 4 over x all over delta x. Is that what I want to have? Let's do, it'd be just a 4. So if you were asked what f is on this one and what's c, okay? So what I have here is f of x plus delta x. I always look for this one. So this has a c equaling 1 or an x equaling 1. So this is actually, the function is 4 over x. And you might say, well, then why is there a minus 4 right here? Because it always goes minus f of x. So if f of x is equal to 4 over x, and I'm doing it at 1, then that becomes a 4. So really, you just spot this and you replace it with an x. Just like in reverse, everywhere I saw an x up here, I put an x plus delta x in. Well, every place you see an x plus delta x, which is just right here, you put an x in, you go in reverse. And keep in mind then that this must have been the x value that got plugged in. So it is kind of complicated. Luckily, you don't ever have to evaluate it, but you do need to recognize it. All right, that's it. Have a great one. If you're doing this, you're studying, and you're going to be glad you did. Not glad you studied, but glad you actually watched these specific ones. So kudos to you. You'll know why tomorrow or the next day. Sorry, I'm trying to get my, I'm still on my highlighter here. I can't say goodbye until I can get off of it. Come on. Oh, good Lord. Oh, that's because I'm on the pen. I'm sorry. Let's get you out of there. Go to you. I'll be able to log out here eventually. Let's get rid of all the dots.